Yeah. Prove that secant A into 1 minus sin A into secant A plus tan A is equal to 1. So here equal sign is there. Before the equal sign, this is called LHS. LHS means the left hand side, and after the equal sign, whatever is there, that is RHS. RHS means right hand side. Now, so to prove, either we have to take LHS first or RHS depending on the type of problem. But here, see, left hand side, it is not in simplified form. But you can see on the RHS side, just one is there, that is simplified form. So we have to understood that we will get an idea that we have to take LHS and then we can prove LHS is equal to RHS. So first consider LHS. First I will write answer. I will write LHS first. So LHS is equal to this entire thing you write. Secant A 1 minus sin A into secant A plus tan A. Okay. See, secant A tan. This sin A is there, no? See, you know, right? Secant A can be written in the form of sin cos A. Tan A can be written in the form of sin and cos because there we have formula for them. So just think, when everything is in the form of sin and cos, then the simplification will become easier. So for that, what you do, first I will convert the secant A into sin and cos form, either sin or cos, or if we have both sin and cos, that is also fine. Okay. LHS, see, secant A is what? 1 by cos A. We can write secant A as 1 by cos A. This is formula. We have standard formula. Okay. Next, this bracket 1 minus sin A. 1 is in simplified form sin A. We want everything in sin A and cos A form, right? So sin A is already there. So just keep it as it is. So I will write this as it is 1 minus sin A. Open this bracket. Next, secant A we can write like this, 1 by cos A. This secant A I am writing as 1 by cos A, and this plus tan A. So how can we write tan A in the form of sin and cos? It is sin A by cos A. Sin A by cos A. Tan A is equal to sin A divided by cos A. This is also a formula. Okay, we have to remember. So next, what we can do? See, 1 minus sin A is there, no? Here nothing is there means in the denominator we have 1. So this is numerator, 1 minus sin A also in the numerator. This cos A is in the denominator, this 1 is in the denominator. So multiply this numerator separately. 1 into 1 minus sin A. See, 1 into anything we will get the same thing. Andre, that means if you multiply this 1 by this, we will get the same thing. So 1 into 1 minus sin A, we get 1 minus sin A only. Okay. Now write this line. Now this numerators we multiplied, this 1 and this. Next denominators you consider. Cos A is there, here 1 is there. Cos A into 1, we get cos A only. Okay. Next, when it comes to your see, your first, see, you can see this, open the bracket first. See, these are the numerators. This is numerator, this is numerator, and this is in the denominator, this is in the denominator. Okay, so we can see denominators are same. Cos a, cos a, denominators are same, and it is plus symbol is there here. That means what plus means what? We have to add this and this. Okay, so while adding anything, if denominators are same, write the denominator as it is only once. Since denominators are same, I am writing the denominator as it is, but you have to write only once. See, cos a here 2 times is there. Here cos a, here cos a. But while writing here, we have to write cos a only once. I am writing only once cos a. Next this line. Okay. Next, since denominators are same, I am writing cos a as it is here only once. Since denominators are same, we can add these numerators, this and this directly. That means 1 plus sin a, you can write as it is. Okay. When these denominators are different, here also cos a, here also cos a. For example, in place of cos a, there is something else like a 3 or sin or secant. That time the process of addition is different. Here, since denominators are same, you have to write this cos a as it is first in the denominator. Then add these numerators directly. 1 plus sin a. So I have written 1 plus sin a. Okay. Now, so this is denominator, and this 1 minus sin a is in the numerator, 1 plus sin a is in the numerator. So multiply these numerators together. First I will write this 1 minus sin a, 1 minus sin a. Next write this 1 plus sin a into next. Here it was plus addition. So here I have written cos a only once. Here see nothing is there. Nothing is there means here into is there. When there is multiplication, you have to write cos a 2 times. Cos a into cos a. Say cos a same. Okay. But we have multiplication. So we have to write cos a 2 times here. Cos a into cos a. This cos a into this cos a. But when it is addition, if here cos a, then we have to write cos a only once. Okay. I hope you got it. Next you see here I will write. Consider this and this. These are in the form of a minus b into a plus b form. Okay. In place of a we have 1. In place of b we have sin a. See, a minus b, a plus b. Okay. So this and this in the form of a minus b into a plus b. We know that a minus b into a plus b is what? A square minus b square. So this is the identity. Okay. This is the identity. In place of a what we have here? 1. So a square means that is 1 square. This minus b. In place of b what we have? Sin a. B square means sin square a. Next step, 1 square means 1 into 1. We get 1 only. So 1 square is equal to 1. This minus sin square a. Okay. So this entire thing we can write this 1 minus sin square a. I am writing here. Whole divided by cos a. Cos a into cos a, cos square a. It's just like a into a is equal to what? A square. So cos a into cos a, we can write cos square a. Got it? Next step here, 1 minus sin square A is what? We have a formula. 1 minus sin square A is equal to cos square A. Cos square A. So just remember, to prove these kind of identities, trigonometric identities, we should know the formula. Trigonometric formulas are there, so many formulas. Without knowing those formula, you cannot solve this kind of problems. So 1 minus sin square A is equal to this cos square A. I am writing this line. Next, so 1 minus sin square A is equal to cos square A, and this cos square A is as it is, you write. Okay. See, here also cos square A, here also cos square A. So we can cancel it. What is left here? 1. So this is equal to, when we cancel this and this, we are left with 1. So 1 is what? 1 is RHS. Okay. So we have taken LHS and that is equal to RHS. That means we have proved this LHS is equal to RHS. So we have taken this LHS, and after doing all these things we got 1. That means this LHS is equal to this one. LHS is equal to RHS. Okay. When we get LHS is equal to RHS, that means we have proved this identity. Okay, we have solved this problem, we got the answer. So this identity is proved. That's all. Done. We are done with this, solving this problem. Okay. Thank you. Click on subscribe.